So when we want to graph the parent function secant, we need to recall that that's the reciprocal of the cosine. So when we evaluate secant of pi over 4, we take the cosine of pi over 4, square root of 2 over 2, and we need its reciprocal, 2 over square root of 2. Then we're going to rationalize that denominator by multiplying the top and bottom by root 2 over root 2 to get 2 root 2 over 2. And those 2's out front cancel, and that simplifies to the square root of 2. So the secant of pi over 4 is the square root of 2, and our decimal approximation for that is 1.4. Okay, then the reciprocal of 0, if you recall, that's a 0 over 1. And when we flip that fraction, we get 1 over 0. And thou shalt not divide by 0, which makes the secant of pi over 2 undefined. And the symbol we use for undefined is a circle with a slash through it. So when you see that, you know that the function is undefined at that x value. What happens on the graph at values where secant is undefined? That is where we're going to place a vertical asymptote, just like we did with the cosecant function where it was undefined. So our first vertical asymptote is going to be at pi over 2. We see here at 3 pi over 2, the cosine is 0, which means the secant will be undefined, so we'll also have a vertical asymptote at 3 pi over 2. Okay, then at 3 pi over 4, we're in quadrant 2 where secant is negative, so this will be a negative square root of 2, or negative 1.4 as a decimal approximation. At pi, the reciprocal of negative 1 is negative 1. Then 5 pi over 4 is quadrant 3. Secant is negative in quadrant 3, so that's a negative square root of 2, or approximately negative 1.4. 7 pi over 4 is the fourth quadrant. Cosine and secant are positive in quadrant 4, so that's going to be a positive square root of 2, or approximately 1.4. Then at 2 pi, the reciprocal of 1 is 1. So let's go ahead and sketch those points on the graph, and we're going to start with our vertical asymptote at pi over 2. And then our next vertical asymptote is at 3 pi over 2. And if we subtract those, 3 pi over 2 minus pi over 2, that's 2 pi over 2, or pi units between each of these vertical asymptotes. So the asymptotes are located at x equals pi over 2, that's our first non-negative vertical asymptote, plus or minus k times pi, where k is an element of the integers. And so we'll go back 1, 2, 3, 4 to negative pi over 2, and we'll have a vertical asymptote there. Then 1, 2, 3, 4, negative 3 pi over 2 will be another vertical asymptote. Okay, so let's plot our points now. Pi over 4 has a secant of root 2, so we'll go up to 1.4 and put a point there. Then at 3 pi over 4, we have a negative root 2. At 5 pi over 4, another negative root 2. 7 pi over 4 is a positive root 2. And then at pi, we have our relative maximum of negative 1. At 2 pi, we have a relative minimum of positive 1. And if you recall, when we sketch those curves, we stay inside the vertical asymptotes, going through the anchor points to get these alternating U shapes that are up and down facing. So if we repeat this pattern then we can fill in our values from negative 2 pi to 0. And then we can sketch those alternating U-shapes to the left of the origin. So our secant function is alternating U-shapes, just like the cosecant that we did last time. Alternating U's. Okay, this secant function, though, does not have a vertical asymptote along the y-axis like cosecant did. So it does have a y-intercept, and that is located at the point 0, 1. Just like cosecant, there are no real zeros, so that'll be a none. And the period is the same as cosecant, that's 2 pi. When we go from one upward facing U, one downward facing U, then our pattern repeats, and we can see that that's 2 pi units across for the period. Our extrema, we have, instead of absolute extrema like we had for sine and cosine, we've got relative extrema. So we have a relative max of -1. Remember, relative maxima are hills, tops of hills. And then the valleys will have a relative min of +1. And those are the valleys, or the low points. Okay, our domain is all real numbers except these undefined values for x. And those occur at those vertical asymptotes. So x is all real numbers except pi over 2 plus or minus k pi, where k is an element of the integers. And the range, starting at the bottom, -infinity, we rise up until this relative maximum of -1. That's inclusive, so we use a bracket. Then union, and we're going to pick back up after this gap here at our relative min of 1, and then head off to +infinity. Okay, there is no amplitude because amplitude is half the distance between the absolute extrema, and since there are no absolute extrema in our secant graph, there can't be any amplitude that we speak of. So now let's take a look at constructing the secant function in this GeoGebra applet. And we can see in quadrant 1 that half of the upward facing U. Then when we reach 90 degrees, that's our vertical asymptote. And then coming into quadrant 2, we get half of this downward facing U. Then we reach that relative maximum at 180 degrees. Now we come back down for the other half of that downward facing U in quadrant 3. And then at 270, we've got another asymptote. And coming back now for quadrant 4, right, we can see it sketching that half of the upward facing U until we reach the relative minimum of 1 when we get back around to 0 and 360.